All right, in this video, we're going to talk about equivalent resistance. By the end of this, you should be able to answer the questions: what are the equations for total resistance, and how are series and parallel resistances similar and different? So let's start off with, what are resistors? There's some pictures of them to the right there. In the lab and discussion we did on Ohm's law, we talked about how resistors affect current. We talked about how the more resistance in a circuit, the less current would flow in that circuit. So resistance holds back current. But the question for today is, what happens when there are multiple resistors in the same circuit instead of just one? So let's talk about resistors in series, like the lab we did recently. So when resistors are connected in series, like the picture to the right, we just add them together to figure out the total resistance. So the equation is just Rs equals R1 plus R2 plus R3 and so on. So if we had 7 resistors all connected in series, you'd add all 7 resistors. If you only have 3, you just add 3. However many you have, that's how many you add together to figure out the total resistance. The bottom right picture over here is just an example of a circuit diagram for series resistors. So let's do an example with that circuit. So here's a series circuit with all the resistors connected one after each other, which is in series. So let's figure out what the total equivalent resistance would be. So there's a few resistors in here. We have this first 20 ohm resistor, a second 20 ohm resistor, a third 20 ohm, a fourth 20 ohm, and one 10 ohm resistor. This number down here, this thing I'll outline in red, this is the battery, not a resistance. So we're not going to use that to calculate the equivalent resistance. So in other words, we're just going to do 20 plus 20 plus 20 plus 20 plus 10, which is 90. I seem to be missing a 20 down here. There should be 4 of them. So we do not add the voltage. That's not a resistor. 9 volts has nothing to do with the equivalent resistance. In parallel, things are a little bit different. Like in that lab we did. The lab we did recently talked about we connected resistors in series and parallel. Parallel resistors connected this way would actually decrease the overall resistance in the circuit instead of increasing it. In other words, each one of the resistors in the picture there has its own connection with the battery. So the equation to calculate the equivalent resistance of parallel resistors is this thing: 1 over Rp, which stands for the parallel resistance, equals 1 over the first one plus 1 over the second one plus 1 over the third one, and so on. Solving this equation is not as easy as in series. You can't just add them up. So next class we'll actually go over how to use this equation properly. So this relates to several of those labs we've done recently. Like this one we did on the computer with the light bulbs and the batteries. With that lab, we found that connecting 3 light bulbs in parallel turned out to have they were brighter in parallel than they were in series. So from that evidence, what can we conclude about which circuit has less overall resistance? In this case, the parallel circuit has less resistance since more current is flowing through the parallel bulbs than the series bulbs. So since it's in parallel, the circuit on the right in that picture, they have less resistance, meaning more current is able to flow through them, making them brighter. So thank you for watching this video. Make sure you bring your notes with you to class and use them to help you answer the equivalent resistance video questions in Schoology. Thanks for watching.